All right, so in the last few videos, we did quite a few examples of solving for missing sides and missing angles using the law of sines. And in this video, I'm going to show you how to look at triangles that look very similar, but how to know that you're going to use the law of cosines. So before we get started, let me just remind you of the law. So I'm going to do one version of it. So we usually start with one of the side lengths squared. We take the two other letters that we didn't use, square. We do minus 2, those same two side lengths. And then obviously it's the cosine law, so we have to use a cosine, and then the capital version of the letter that we started with. So if you start with lowercase a, you will end with capital A. If you start with lowercase b, you will end with capital B, etc., etc. Okay, so let's go to our triangle and let's figure out what we know and what we don't know. Okay, so I see right here capital A, and it is 35 degrees. I see across from capital A should be little a. I don't know that. I see angle C. I don't know. Angle B, I don't know. So this is very clearly an example where more sides are known than angles are known. So this is side, side, and then if this is across from angle B, this would be little b if this is across. Okay, so what do I know? So I know angle A is 35 degrees. I know lowercase b is 7. I know lowercase c is 9. And I want to know, sorry, I just noticed a little error in the question. It says AC, but we obviously know that, so I believe this should have been BC. So we want to know how long is this side, right? What we call A. Okay. So the reason why I would say it's very obvious that this is a law of cosines example is because you already see that all three sides are involved. Right? We have knowledge of all three sides, and we only have knowledge of one angle. So this is a perfect opportunity to use the law of cosines. So let me go ahead and set it up. So it's just like we wrote up there. So if we want to know a squared, that's how I know to start with a squared, is this is what I'm solving for. So that's how I know what to start with. So we have a squared equals b squared plus c squared minus 2 times b times c times cosine A. Okay, so just a heads up, you can already tell that this is going to be computationally a little bit more involved than the law of sines. With the law of sines, it was a very simple, just plug in, cross multiply, and get what you want. But this one, it's going to be a little bit more, you got to be careful. So a squared, I don't know. B is 7, so that's going to be 7 squared. C is 9, so that's 9 squared. Minus 2 times 7 times 9 cosine of 35. And this one is very straightforward because as you can see on the the right-hand side, everything is known, which is great because that means that I don't have to get anything by itself. The variable that I'm interested in is already over here by itself. Well, it's already isolated, but with a square. So we'll deal with that in a second. So I'm going to go to Desmos, and in Desmos, I'm going to put all of this cosine. Sorry, I'm writing it down so I know what to put. Okay, so let's go back to our friend Desmos. And what I want to put is 7 squared plus 9 squared. Oops, that's not squared. 9 squared minus 2 times 7 times 9 cosine 35. And let me just check that I'm in degrees. Yes, I am. And so it looks like that's going to be 26.787. I'm going to round to 3 decimals just to be as precise as possible. So 26.787. So my a squared is 26.787. Okay, but if you notice, this is a squared. I don't want a squared. So how could I get rid of that square? Hopefully in your head you're screaming, take the square root. And so that'll give us a better approximation of a. So let me go back to Desmos. Let me square root this number. And let's see. So I'm going to do square root of, I wonder if I could copy, can I? Well, I tried. Okay, 26.7868424196. And so the more decimals you put, the more precise your answer will be. So I recommend putting as many as you can. But even if you only put 26.787, you'll get pretty close. So I would say the answer is 5.176. 5.176. So A is approximately 5.176 units. Yay. Okay, so that wasn't too bad. Solving for a missing side is pretty straightforward, not too complicated. But finding a missing angle can be a little bit more crazy. So let's see. Now we're going to go